Hello students, welcome back. This question is from GATE 2007 exam. It's for 2 marks. In this table, they have specified how a 4-bit counter works. And using this 4-bit counter, they have made this circuit. Okay. So inputs to this counter are all of these signals. And this is the 4-bit output of the counter. We need to find out the counting sequence at this output. Okay, they are saying initially the value is 0, 0, 0, 0. So A1, A2, A3, A4, all of the bits are 0. Now, you can see count signal is permanently 1. That means we are asking this counter to keep on counting. Load signal is permanently 0. We are asking this counter not to load anything. See, count is equal to 1 means just whatever is the current state incremented by 1. That means keep on counting. If this load signal is 1, that means whatever is the input, the 4-bit number, load it as it is. This signal is used if you want to begin counting from a specific number. For example, if you want to begin counting from 3, you input 3 here and tell the counter to load that input. Okay. Now, because this is 0, that means input is of no relevance. Just neglect this input because we are keeping the load signal equal to 0. Okay. This is the first state. Whenever a clock signal is given, it will go to 0, 0, 0, 1 because count is high. Okay. Now you can see when in this state, this AND gate will output 0. Clear signal is equal to 0. That means counter will not clear the output. Okay, just see this table. If clear signal is 1, that means clear the output to 0. If clear, load and count, all three are 0. This one and this one is 0. Then nothing will happen if you give a clock or even if you don't give a clock. There will be no change. If load is 1, that means we are asking to load. Then upon seeing a positive edge of clock, the input will be loaded. Whatever is this will be loaded. Similarly, if count is 1, upon positive edge of clock, we will count the next number in the sequence. Okay. Now at this point, value of AND is 0. That means clear is 0. We are not asking the counter to clear. Okay. So a positive edge of clock is seen and we shift to this state. Here also 0 and 1. It will be 0 only. Okay. So this output is still 0. Upon seeing a positive edge of clock, we will go to state 2. 0, 0, 1, 0. 0 and 0 is still 0. Okay. This output will be 0 only. And upon seeing a positive edge of clock, we will go to the next state because count is 1. Okay. So after 1, it will be 0, 0, 1, 1, 3. Okay. Similarly, upon seeing next positive edge of clock, the state will be 0, 0. Sorry, it is 4. That means 0, 1, 0, 0. Then next state will be 0, 1, 0, 1. Okay. So first clock, second clock, third clock, fourth clock, fifth clock. Upon seeing the fifth clock, the output will be 0, 1, 0, 1. You can see this A3 and A1. Both of the bits are 1 for the first time. This AND gate will output 1 and a clear signal will be given to the counter. Okay. That means after this output will be 0, 0, 0, 0. Okay. So some of you might get answer as 0, 1, 2, 3, 4, 5, 0. Okay, you might say the answer is 0, it goes to 1, then 2, then 3, then 4, then 5, and then it goes back to 0. This is wrong because if clear is 1, we need not wait for a clock signal. As soon as clear is 1, immediately the output will be cleared. Okay. So here we will wait for the clock signal. Here also, here also, here also, here also. But as soon as this clock signal is received, output changes to 5. Immediately this AND gate will output 1. The counter will be cleared immediately. We will not wait for any clock signal. See, I haven't drawn a positive clock here. This will be 5 for very small moment of time, like for a few microseconds or maybe even a few nanoseconds. Okay. Immediately the value will be 0. After that, we will give a positive clock. Okay. Then now upon positive edge of clock, you can see 0 will go to 1. Okay. That means this sequence will start from beginning again. That is, state 5 will not be in the counting sequence. It is like this. So your answer is 0, 1, 2, 3, 4. That's it. Because you just give some time to the circuit to stabilize. Okay. As soon as 5 is seen, the circuit is not stable. Changes are still happening. Okay. This will go to 1 very quickly. So 5 is not the state. Upon seeing this clock, stable value is 0. Okay. So answer is 0, 1, 2, 3, 4 and then back to 0. Okay. Yeah, so I forgot to mention one thing. In question, they are saying that gates have negligible delay. That means as soon as output of this counter becomes 5, immediately at that time only this gate will start outputting a 1. So clear signal is 1 and immediately this counter will make the output 0 again. Okay. So this will happen very quickly. That is the reason we can skip 5. Okay. But the main reason is that upon seeing this clock signal, circuit takes time to stable, so the final value will only be considered. Okay. See, clear signal will not wait for any of these signals. All of these are don't care. As soon as clear signal is given, immediately counter will clear the output. So this is the stable value. Okay.